making a synthesizer, usually, well, the voltage controlled oscillator that I made a video of, it's the last one of it. When you make a voltage controlled oscillator, the frequency is determined by the capacitance and farads and the resistance of the feedback resistor. And I don't like doing math when I'm making synthesizers, so instead of doing the math and trying to figure out what would be the best resistance, I thought it would be cool to just have like a little circuit that you could put into your VCO to test out different resistances. And I came up with that idea like this morning when I was making that synthesizer, and I did it right here. That's an 8-pin dip switch. You can see a going from starting on 1, that's 1K, then 4.7K, then 10K, then 22K, then 47K, then 100K, then 200K, and then 1 meg. It's wired like this. All of the switches are wired to one of these two main points. The switch is wired that way, and then the other end of the resistor is. So I'll show you this in action. My little multimeter. And this guy. I will connect this to here. Right now there's nothing selected, but we're just going to go up. The range will start on 1K. So you should see change right here when I click this. So now I can go into the circuit and put in, I thought it was 1% tolerance. That's 1.5%. I can go in and put this right here using these two leads. I can just attach this into any VCO, and I can test what would a 1K resistor look like in this RC circuit. What about a 4.7K? What about a 10K? Okay, what about a 22K? Okay, what about a 47K? A 100K? A 200K? And finally a 1 meg. Is that not cool or what? Now what's also cool is, like, let's say I want to do 1 meg and or 1.3 meg. This is in series. Well, it should be. It's making a decrease. Why is it doing that? I have no idea. I guess that's wired incorrectly somehow. Huh. I guess when you do them in series here, that they actually do not add up the way I thought that they would. Oh, because I guess they're not in series. It's 2 parallel circuits. Anyway, you get the idea. I guess you can only do 8, but I was thinking that you could do like 100 or 200 plus 100, but you can't. What you will get is 67% because 100 is or 200 and 100 is 300, and 200 is 67% of 200. Let's see if that's true if we do things like keep this 100, or maybe do that 100 and then this 1K. Yeah, it should be close to 1, because that's 1%. 100, and then 10K should be close to 10. That's 20. Almost close to 20. Should be, well, because 20 is, I mean, this is percentage. This is not, like, this is 47. What is 47 plus 100? It's 147. What's 47 divided by 147? That's probably 32%. 47 goes into 147 3 times, so 3 times 47 is 141. 141 goes into 140. Yeah, that's right. That's so weird. Well, unfortunately, these dip switches have really shaky legs, and this is the only one where I actually got 8 of them. And I was going to put another dip switch right here and have 8 different capacitor values so that I could just have this little module as my little testing circuit. But I need to get more dip switches because all of mine broke. So, I don't know, is that not cool? I think that's pretty cool, because that's going to save me a lot of time, because I spent so much time just soldering in resistor into a VCO, and then unsoldering it because I didn't think it sounded good. Oh, here's another dip switch. I have one right here. Oh, yes! I guess I do have one with the legs. Nice. These things are so tricky. They do not like being moved. Or, I guess you just gotta move them real slowly. Oh, well, I guess I'll have the capacitor part of this circuit done soon as well. I think I just busted one of them by moving it too fast. That one may be busted. Well, anyway, you get the idea. I guess I'll make the capacitor one tonight as well. And then I can... It'd be nice if I had a bigger one, and then I could just put one of these, where'd it go? Where'd I just have it? I could put, if I had a bigger one, I could just put one of these TL074s in there, and then just have this be the feedback circuit, and I can just switch it all over the place. The feedback of a VCO needs to be 180 degrees out of phase when it's, and that's how you end up getting the oscillation. Huh? Perfect. Alright. Couldn't be any more perfect. Thank you. I hope you enjoyed this, and I guess I'll make schematics for this if you want to make one of these. It's pretty cool.